that's waiting.
Yeah. Any technology can be used for the benefit of mankind and against the mankind. And in fact, if you think about, for example, using nuclear, I guess, technology, we can use it to generate energy, or we can use it to produce mass destructive weapons. So it's the same way. Biotechnology can be wonderful if it is used properly to cure many diseases, and even replace defective genes in people, and change organs in people. And yet it can be used in a very negative way if not properly controlled. So it is not really the technology that we should be afraid of, but it is the way we can implement the use of technology.
We have two more quick questions we're going to try to get in, even though we're technically out of time here. The first is from Ecuador. It's from MR y Compañía Consultores in the city of Manta in the country of Ecuador.
Very good morning. We are greeting you from Manta, Ecuador, and the question is... Perdone, aló. No se escucha. There was a lot of sound interference, and we couldn't really hear I think her question had something to do with values and ethics and environment. I'm sorry.
Well, let's do this. If Dr. Thomas, if you could quickly just make a comment on ethical values and their application to the environment.
Well, actually, I'll quickly address it from the standpoint of science and ethics in the workplace, and especially now that we have public-private partnerships. It is very important that at all levels, the businesses as well as the sciences, that we act in an ethical way, always in all, even the society or individual level. And this question came up at the American Society for Microbiology, that the publishers of documents dealing with these issues must also select articles that are ethically sound. And so we have many areas and levels where we need to adhere to our ethics standards.
Our last question is going to be from Mexico. It's from the Universidad Nacional Autónoma de México. It's the Facultad de Medicina Veterinaria y Zootecnica. It is in Mexico City, Mexico.
Oh, we're from Cuautitlán, Mexico State. First of all, we want to greet you, and then please comment on the effect of the products that have been marketed and that apparently are being sold, saying that they're safe, especially pesticides, and that have very high cancer-causing products and agents. And what are the implications of having in the society, in the shelves, all these products that are being sold that are really bad for our health, and how can we address that? What can we do?
Dr. Gurol?
Yes, this is a wonderful question. The chemical industry in general comes up with hundreds of compounds on a yearly basis, new compounds, and many of those, fortunately, are tested. Now that we have new rules, those are tested on animals, on humans, and for the impact on ecosystems, but many don't. And we also continue to find out that the products that were out there that we believe to be safe now becoming more problematic. And then when we discover that, and how do we discover that, is because the science is progressing very rapidly, and we can now detect the cause and effect relations between, for example, a chemical and the chemical dosage versus what kind of effect that chemical cause on different environmental components, human beings and others. And this way, we find out that those are becoming problematic. For example, for pesticides, we knew that DDT was safe, and or at least we believed that it was safe a long time ago, and then we discovered that it wasn't. So it's now banned in many, many nations, except probably only in India. And similarly, many chlorinated type of pesticides, we are now finding out that they linger, they resist in the environment, therefore they accumulate in what we call the food chain and eventually cause cancer. And so we are progressing from that to more safer chemicals.
We need to stop. We have many questions, and I thank you for those questions. They're excellent. Let's now move to the second module of our program, where Dr. Gurol will look at how to manage environmental changes that we face.
Thank you. What is responsible management of environmental quality? This presentation aims to provide an understanding of this concept while offering some examples from practices primarily in the U.S. Responsible management of environmental quality involves three seemingly different considerations. 1. Protection of the human health at the workplace. 2. Protection of the public health. And 3. Protection of the ecological health. Protection of human health at the workplace is essential for moral reasons and for the success of any organization. Improving the conditions in the workplace enhances the well-being and the morale of employees, resulting in higher productivity. The primary consideration in this area should be employee safety through prevention of work-related accidents. In addition, a clean and safe environment should be created to protect employees from acute and chronic illnesses. This can be achieved by controlling the air quality, the noise level, and other factors that might affect the employee health. Let me tell you about a bad management practice that I witnessed in the early 1970s in a metal plating shop in Turkey. Some of you might know that the conventional metal plating process requires the use of hazardous chemicals, including strong sulfuric acid and cyanide salts. Metal pieces are first submerged into acid baths to remove oil, grease, and dirt from the metal surfaces, and then dipped into the plating baths that contain cyanide salts. Strong acid easily evaporates into the air from the acid baths. In addition, when acid-dripping metal pieces are carried into the cyanide baths, the chemistry of the solution changes, making the cyanide evaporate into the air as well. The workers breathe acid and cyanide fumes if the baths are not covered, if drying of the acid is not incorporated into the process, and if the workplace is not ventilated properly. The mixture of corrosive acid with the toxic cyanide fumes makes breathing very difficult for the workers. They can even die after prolonged exposure. This was the picture that I witnessed in early 1970s before Turkey adopted environmental regulations in this area. Today, the picture is very different in Turkey, as well as in many other countries where the health of workers is protected by governmental agencies. For example, in the US, the Occupational Safety and Health Administration, that's OSHA, is in charge of issuing and enforcing health and safety regulations at the workplace. OSHA sets exposure limits, not only for highly toxic compounds such as cyanide and ozone, but also sets limits for noise levels to prevent hearing loss. In addition, OSHA regulates chemicals that are believed to be carcinogenic under long-term exposure. An example is formaldehyde, which might be emitted from insulation and carpeting material even in office environment. In fact, the so-called sick building syndrome is rather common, especially in old buildings and buildings that have little ventilation. In these buildings, the residents may feel headaches and dizziness and may exhibit allergic reactions. The OSHA is also in charge of setting standards for the indoor air quality in buildings. Owners and operators of private, public, and governmental businesses and organizations should be observant of the regulations and do their utmost to create a safe environment for employees. Cooperating with regulators will help the organization avoid the fines that can be imposed by these regulators. In addition, compliance with the regulations will prevent long-term liability that might cause bankruptcy if the workers take legal actions against the company. A future ITC program will touch upon balancing health with the work environment in more detail. The second consideration in responsible management of environmental quality is the protection of the public health. Governmental agencies are usually in charge of imposing regulations to protect the public health. In the U.S., the main federal agency that issues and enforces the environmental regulations is the U.S. Environmental Protection Agency, that is U.S. EPA. Different countries have different health problems, different economic realities, and different development priorities. In many developing countries, microbiological contamination of drinking water and the risks associated with diseases such as cholera, hepatitis, typhoid, and many other infectious diseases are the most pressing public health problems. In these countries, populations lack the simplest disinfection capabilities and a reliable water distribution system to deliver water to residences. They may therefore prefer to spend money on improvement of these basic infrastructures. On the other hand, some countries are concerned about the long-term health effects of the chemicals that might be present in minute quantities in drinking water. These chemicals include pharmaceuticals, healthcare and beauty products, industrial solvents, and other synthetic chemicals. In addition, chlorine used in the disinfection of drinking water is known to produce certain chlorinated organic byproducts that are suspected carcinogens. In the U.S. and many European countries, the concentration of these chemicals in water is kept below certain regulated levels. This is done by either switching from chlorine to alternative disinfectants, such as ozone, or by adopting other relatively expensive process modifications in water treatment plants. Whether the problems faced are different or similar in nature, environmental regulations should be flexible, taking into consideration local realities and economic priorities. On the other hand, the developing countries can learn a great deal from the past experiences of the developed countries and be wise enough not to repeat their mistakes. For example, the developing countries might decide to pay more attention to the protection of water resources from chemical and biological contamination rather than to extensive treatment of the water after it is contaminated. This is because water treatment is much costlier than resource protection. Furthermore, rather than the conventional chlorination technology, the developing countries might opt for new disinfection technologies such as ozonation when constructing new water treatment plants. This will help eliminate costly plant modifications later. Let me present an interesting case study as another example of the lessons that can be learned from the experiences of others. This case involves methyl tertiary butyl ether, that's MTBE, which is a chemical used as a gasoline additive. The story began in the 1970s in the US when the EPA decided to eliminate lead from gasoline since lead was discovered to cause adverse effects on mental capabilities of exposed people. Gasoline refiners needed a replacement to boost octane and extend domestic supplies of gasoline. Out of this came MTBE. MTBE was seen as a pretty safe chemical. So, in 1979, MTBE began to be used as a gasoline additive. In 1990, the use of MTBE was mandated by law since MTBE also reduced emissions of chemicals such as carbon monoxide and ozone from vehicles, and thus helped reduce air pollution in urbanized areas. The use of MTBE skyrocketed. It was added to gasoline at levels as high as 15%. Many people started to complain about dizziness, nausea, and headaches, and blamed the problems on MTBE. In 1996, another problem was discovered. MTBE was finding its way into drinking water supplies. Major sources of MTBE in the groundwater supply were leaking underground storage tanks, pipelines, landfill sites, and refueling facilities. Since MTBE is highly soluble in water, once it entered the groundwater, it spread extensively. At very low levels, MTBE was tasted and smelled in water. Since MTBE was not biodegradable, it did not disappear in groundwater over time. MTBE contamination caused many groundwater wells to be shut down in several communities. Many other communities continue to spend money to remove MTBE from their drinking water. The chemical industry has been caught in the middle of an ongoing debate. The industry has built up huge plants and complex distribution systems. But MTBE is likely to be gone as an additive in the next few years, leaving the industry with a lot of useless capacity. This case clearly demonstrates the need for a full environmental impact assessment before implementing a decision that involves widespread use of a chemical such as MTBE. The third consideration in responsible management of environmental quality is the protection of the ecological health of the environment. Ecological health can be defined as the natural state of undisturbed habitat. Some might view the protection of the ecological health as a luxury for the developing countries. Yet, the public health is directly linked to the ecological health. For example, a land developer might decide to decimate wetlands to construct commercial property, such as luxury hotels and residential buildings at a coastal area. Waters, such as small streams and storm runoff, flow through the wetlands, before reaching the ocean. Wetlands serve as a filter, trapping and removing many contaminants in waters, including disease-causing microorganisms, nutrients, toxic organics, and metals. In the absence of the wetlands, those contaminants easily find their way into the ocean. Nutrient loads stimulate algal blooms in the water. People who come into direct contact with water might get sick through exposure to algae and other disease-causing organisms. In addition, disease-causing organisms and toxic chemicals that find their way to the ocean are digested and accumulated by fish and shellfish. Contaminated fish and shellfish might cause major health problems in people who consume them. In this example, the actions taken by a land developer resulted in a deteriorated beach and in various health problems in people. That is just the opposite of what was expected from turning the wetlands into a tourist attraction. Let us discuss another case where developing countries can learn from the mistakes of more industrialized countries. In the US, rapid industrialization, accompanied by the lack of understanding of its environmental impact, caused extensive, uncontrolled disposal of industrial waste up until the 1970s. Many companies dumped their hazardous waste onto open lands or injected them into deep wells. Others buried waste in drums, which leaked their contents into the surroundings over many years to come. This is a schematic of how waste disposed improperly can spread in the environment. We see 4 different disposal methods here. Liquid or solid hazardous waste is disposed in open disposal ponds or buried in uncontrolled landfills. Another disposal method is the injection through deep wells into the underlying aquifers. Finally, chemicals such as gasoline or solvents can accidentally spill or leak from broken pipelines into the environment. Over time, chemicals penetrate through the soil and find their way into groundwater supplies. They then spread further with moving groundwater. The chemicals reach wells, rivers, and lakes that communities use as drinking water sources. Extensive contamination of soils and groundwater due to uncontrolled waste disposal was first discovered in early 1970s at a location called Love Canal in the state of New York. Chemical fumes penetrated through the soil and reached the homes in several neighborhoods, forcing the residents to abandon Love Canal. Since then, 1,551 sites have been put on a list that is referred to as the National Priorities List. This list contains only the abandoned sites that have no identified owner. The list is updated as sites are cleaned and new sites are discovered. To date, 257 sites have been completely cleaned up. An additional 552 sites have been partially cleaned up. At these sites, groundwater contamination remains a problem that will take years to remedy. The impact of the groundwater contamination in the U.S. is quite significant, considering that about 50% of the population relies on groundwater as their major water resource. Cleaning up of a contaminated site is a very expensive operation. Each site might cost from a few $1 million to up to $1 billion to clean up. Over the last 14 years, about $22 billion were spent for cleanup efforts. Over the next decade, it's estimated that another $14 billion will be needed to clean up of an additional 300 to 500 sites that might be added to the national priorities list. Part of the cost is recovered from the responsible parties if they can be identified. Otherwise, the cost is shared by the taxpayers and the taxes imposed on chemical and oil companies. The financial burden of this effort on the whole nation is quite obvious. Many developing countries cannot afford this type of an expense if they face a similar problem. Therefore, it is crucial that they learn from the mistakes of others. They should take necessary precautions to control and properly dispose waste in order to protect the environmental quality. The environment has different assimilative capacities for different types of pollutants. This is where the governmental agencies, such as the EPA in the US, step in and set standards for maximum concentrations of the pollutants. The standards could be set as ambient standards or as discharge standards. The ambient standards provide maximum concentrations allowed in the receiving water or in the ambient air. For obvious reasons, the ambient standards are stricter for pollutants that are more toxic and hazardous. The discharge standards are set for each industry based on 1. The acceptable ambient standards for the receiving water or the ambient air. 2. The type and the quantity of the discharge pollutants. And 3. Other discharges to the same receiving water or the ambient air. For example, the discharge standards are generally stricter in heavily industrialized areas where there might be numerous discharges to the same receiving water or the ambient air. In the US, all the industrial discharges are regulated through a permitting system. When the waste that is generated by an industry exceeds the permitted limits, then the waste needs to be reduced through treatment before final disposal to the environment. Treatment technologies vary depending upon the type of waste or the type of chemicals in the waste. For example, the majority of organic compounds present in wastewaters are biodegradable. In other words, can be converted into innocuous products through the action of microorganisms. Treatment of such wastewaters is relatively easy, less expensive, and quite common. Municipal wastewater contains primarily biodegradable organic material. Wastewaters generated by food and beverage industry, dairies, and petroleum processing also belong to this category. These wastes are treated in biotreatment facilities where microorganisms are used to break down the organic material. Activated sludge systems, trickling filters, oxidation ponds, and digesters are examples of biotreatment processes used in these facilities. Some organic compounds in wastewaters are non-biodegradable or hazardous. These chemicals are either toxic to the microorganisms or simply cannot be broken down in biotreatment facilities. Wastewaters containing such compounds are considered hazardous waste and therefore cannot be discharged to the environment or to the biotreatment facilities of municipal and industrial systems. In the U.S., millions of gallons of such wastewater are handled, transported, and disposed according to the hazardous waste regulations, making it very costly for the organization. Some advanced technologies can be applied to convert these chemicals into products that are biodegradable and hence make the wastewater non-hazardous. I am currently involved in a research project funded by the Water Environment Research Foundation. We investigate 3 different chemical oxidation technologies. These technologies involve the use of ultraviolet radiation, ozone, and hydrogen peroxide. The aim is to use these advanced technologies to convert organic compounds such as PCP, TCE, and MTBE into biodegradable and non-toxic compounds so that the waste can further be treated in biotreatment facilities or discharged to the environment without any adverse effects. The research results so far indicate that all 3 technologies are capable of degrading the test chemicals effectively. In the U.S., about 60% of hazardous waste is generated by the chemical industry. The total amount of hazardous waste generation is estimated to be 200 to 300 million tons per year. More than 95% of this amount is hazardous wastewater or aqueous liquid waste. About 75% of the hazardous wastewater is treated and then discharged into the environment. The rest is treated and discharged to sewer systems for additional treatment in municipal plants or disposed by deep well injection. In spite of all the advances in the waste treatment and disposal technologies, the approach to pollution control is changing rapidly in many countries. Now, more emphasis is being given to waste prevention or minimization than to waste treatment and disposal. This is because the treatment and disposal of the waste is proving to be more costly than waste prevention and minimization efforts. This figure shows waste minimization hierarchy, ranked in the order from the most desirable to the least desirable practices. At the top of the desirability rank is the source reduction. Source reduction involves the following efforts. 1. Changing raw material to reduce or eliminate hazardous products. 2. This effort involves adopting cleaner processes that generate little or no hazardous products. And 3, this effort involves using environmentally compatible material. An example is using phosphate-based pesticides that are biodegradable rather than chlorine-based pesticides which are non-biodegradable.